Good afternoon. This one is base level physics assignment related to motion, graphs, and force. Yesterday I discussed the first 12 questions. Today on 12 onward. So, question 13. In this question, a man pulls a box towards him at a constant speed by pulling on the handle as shown. A free body force diagram for the box and the man are shown. So free body force diagram for a box is there, the forces which are acting on the box, the pull of the man, the frictional force is there, the weight is acting down and normal contact is acting up. And then the free body force diagram on the man, the pull of the box, the friction force is there for a man because he's trying to move. The friction is opposing its motion as he pushes the ground, so friction is in towards right hand side, normal contact force is up and the weight is acting down. In the question, identify the pair forces that have the same magnitude due to Newton's third law. So action and reaction forces are equal but opposite in direction. So you can see here that pull of the man on the box will be the pair force for pull of box on the man. So the pair forces are the pull of box on man and the pull of man on box. So action and reaction forces are equal but opposite in direction. Then state one difference and one similarity. So the difference, the directions are opposite. You can see one is point, the directions are opposite, and what will be the similarities? Magnitude will be same, but already they mentioned that they have the same magnitude, so you have to mention any other thing. So you can mention they will have the same type of forces or act for same time or same line of action. So difference, their direction, and similarity, they are same type of forces, or you can say same line of action, or you can say same time, acting on the same time, at the same time. The next question, angle between the pull of the man on the box to horizontal is 35. The mass of a box is 85 kilograms. Show that the pull of the man on the box is about 400 Newton and the normal contact force on the ground is 620. So angle between the pull of the man on the box, so pull of the man on the box to the horizontal is 35. So they give this angle is given 35 degrees. So this angle is 35 degrees. It will have two components. The one which is with an angle, and this force, the magnitude of the force is, we have to show that the pull of the man on the box is about 400 Newton. So this is what we have to show. So this will be F. The one which is with an angle, this will be F cos 35. And against the angle, the vertical component which will be there against the angle, that will be F sine 35. And the weight of the box is also given, the mass of the box is given. So in terms of forces, when we work out, the weight is acting down. In terms of forces, the weight is acting down, the W. The force, the pull of the man on the box is acting up, and the normal contact force is also acting up. So the pull of the normal contact force example are the vertical component of the force, that is F sine 35, and the weight is acting downward. Because horizontally there is no acceleration, so resultant force will be 0 in the horizontal component. So when we write the equation here, we can write R plus F sine 35 minus weight is equals to 0. Why 0? Because this object is not accelerating in that horizontal plane. That's why the resultant should be 0. So the normal contact force is given 620 minus F sine 35. Sorry, this is plus because the two forces are acting in the same direction. So this is plus, and minus the weight, mass into gravity. So mass is 65 and gravity is 9.81, and that result is equals to 0. So when we find the F, this will move other side 620 also and divided by sine 35. So this F will come out 373 Newton, which is about 400 newtons. Is it clear, this part? The next part, the box moves at a constant speed towards the man. Calculate the friction force between the box and the ground. So we have to calculate the frictional force, the force which is opposing the motion between the box and the ground. So same figure we will use. The horizontal component, after getting the value for F, the horizontal component, vertically there was no acceleration, horizontally also they mentioned it is moving with a constant speed, so there is no acceleration. So F cos theta is acting towards right and friction is acting towards left. So friction and this opposing the motion, this is F cos 35. So we can say friction minus F cos 35 is equals to 0. As they mentioned, it is moving with a constant or steady speed. So as it is moving with a constant or steady speed, there is no resultant force. So we can write that the friction minus F, the value of the F was 373, and cos 35, that will be equal to 0. So friction force is coming out as 305.5 Newton. The next part, a man increases his pull on the box. The man and the box start to move together in the same direction with an acceleration of 0.2. Calculate the friction force between the ground and the man. And the mass of the man is 90. So basically, we know the acceleration and the whole system. As I mentioned, the man and the box both start to move in the same direction and they have the same acceleration. So it's like a two body system in which the mass of the box was 85 and the mass of the man is 90, and both are accelerating with 0.02, I guess, 0.2. So both are accelerating towards right hand side or same direction with 0.2 meter per second square. So we want to calculate the frictional force between the man and the ground. So basically, the direction of a resultant force is toward right, and that resultant force is created by a friction between the man and the ground minus the friction between the box and the ground. So when we subtract the two frictions, like friction 1 minus friction 2, that will create a resultant force, and that resultant force will get the acceleration. So we can say the resultant force is equals to ma. And what about resultant force? Resultant force is friction between the men and the ground minus the friction between the box and the ground, that is equals to ma. Friction between the box and the ground, that we already calculated in the previous part, that was 305. So this F1 we don't know, minus 305 is equals to m. But now what is m? Because it's a two body system, like multi-body system, in which the whole object, like box and man, both are accelerating with the same acceleration. So the total mass will be 85 plus 90, and the acceleration is 0.2. So when we calculate the 85 into 90 multiplied by 0.2 plus this minus 305, it will move there. So F1 will come out as 341 Newton. That is the friction between the frictional force between the men and the ground. In this question 14, it's using the graph, what is the acceleration of the ball. So how to work out the acceleration? Acceleration is actually change in velocity divided by time, or final minus initial. So final is 0. If we can take, because it's a straight line, so we can take any interval for the time. So if I take this time interval, the final is 0 and initial is 15. So it will be final minus initial, so u minus 15 divided by 2, which is equals to minus 7.5 meter per second square. B will be the right answer for this. Use the graph total distance traveled. So area, because speed time graph or velocity time graph, here the displacement will be 0 because the area of the object moving upward and downward is same. But what about distance? It will be area under the graph. So it's making a triangle, and for triangle it will be half base into height. So it's starting from 15 to 0, and the base is 2. So this part, area of this part, it will be half, base is 2 and the height is 15. So this will be 15, and same thing, half base is again 2 and the height is again 15. Why we are not taking minus 15? Because we are finding a distance, not the displacement. So this is 15 meter and 15 meters, so total will be 30 meters, the distance traveled by this object. If it was a displacement, then the 0 will be the right answer. Why? Because the displacement is plus 15 and minus 15. But for distance, which is a scalar quantity, so we will not include the sign and we will just use the magnitude. In question 16, an object of weight W is on the slope at an angle theta to horizontal. The normal contact force is R. As the theta increase, the value of R. So what will happen to value of the R? When we use the component, the angle of the inclined surface is same as angle with the plane for the weight. So the component of the weight which is with an angle, that is W cos theta, and against the angle will be W sin theta. So basically R is equals to W cos theta. W is constant. And what is the relation between theta and cos theta? Theta and cos theta are inversely proportional. If value of the theta increase, value of the cosine theta will decrease. So when we increase the theta, so value of the cos theta will decrease, and when value of the cos theta, weight is constant, so value of cos theta decrease, so this component value of R will also decrease. So R will decrease and R is equals to W cos theta, so A is the right answer. Is it clear? theta is directly proportional to sine theta and theta is inversely proportional to cosine theta. Like if we increase the value of the theta, the value of the sine theta increases. But if we increase the value of theta, value of cosine theta will decrease. Is it clear? This question 16. A constant resultant force act on the object. Which of the following graph is correct for the motion of object? So when there is a constant force, there should be a constant acceleration. And constant acceleration means the slope should be constant for velocity time or speed time graph. So which graph slope is constant? For velocity time graph, the slope is constant. It means this is having a constant acceleration, and constant acceleration means there is a constant resultant force on it. And question 18, a camera may be used to determine if a car is exceeding the speed limit. The camera take a photograph at a time interval of 0.5 seconds as a car travel over a set of equally spaced road markings. The measurement from the photograph enable the speed of the car to be calculated. Why the speed calculated is an average speed? Because why we call this an average speed? We are not taking a short time interval, we are taking a total distance. That is why the speed will be average speed. But if we were taking considering the fact that any certain specific interval or short time in short distance or short time interval, in that case the speed will be the actual speed, because we are considering the whole motion, the total distance. That's why it is an average speed. The diagram below shows the position of a car at a time 0.5 second. The markings are painted on the road at interval of 1.52 meter. The speed limit is 50 km per hour. Use the information, determine whether the car was exceeding the speed limit. So we can work out the speed, the distance between the markings. So the distance is 1.52 between each mark. And how many divisions are there? So example, it is starting from second mark and we consider third, fourth, fifth and sixth mark. So how many marking from this it covered? That is 4 markings. And distance between each mark, like this distance is 1.52. So 4 multiplied by 1.52, and that is in meters. So 1.52 multiplied by 4, that is 6.08. But in meter. And we need kilometer to check in the speed limit in kilometer per hour to compare the final result. So we have to divide by 1000. So it will be divided by 1000 to convert into meter, which is 0.00608. That is in kilometers. Sorry. So it was in meter. We divide by 1000, so we convert into kilometer. What about the time interval? The time is in second, which is 0.7. So, but we have to convert into hours. So we divide by 60 to convert into minute, and then divide by 60 to convert into hours. So this will give us time in hour. And then distance divided by time. So that when we just solve distance divided by time, the speed will come out as 46 kilometer per hour. And the speed limit, that is 50 kilometer per hour. So the car is not exceeding the speed limit. In the next question, which is related to vector diagram, forces of 19 Newton and 6 Newton act on an object at an angle 7 and 74. So for this case, there are two ways to solve these type of questions. You can use a parallelogram method or you use a triangle method. Only difference, if we are using a parallelogram method, so if we use a parallelogram method, we should start both vector from same point and we need angle between them. And if we use a triangle method, then we will draw the first vector and the second vector starts from head of the first vector. And in this case, we don't need the angle between them. So basically, like example, how we solve this, if we use a parallelogram, I will use both methods to explain the idea. And here the graph sheet is there. You can select a scale and you will draw accordingly. But I will explain the method, the technique which you will use. So if I use a parallelogram method, first I will scale them because 19 Newton and 16 Newton is not the scale. So first we scale, like if you select 2 Newton is equals to 1 centimeter or 4 Newton is equals to 1 centimeter. It depends on what suitable scale you find. So after selecting a scale, you will draw the first vector, which is 7 degree from horizontal, and then we need the angle between them. So what will be the angle between them? So it will be 74 minus 7. So angle between them will be 67. So we'll measure 67 degrees and we will draw the second vector from the same point but with an angle 67 and with the same measurement like with the scale we select. Then open the compass, like if I select the scale here that 2 Newton is equals to 1 centimeter. So 8 Newton will be 16 centimeter and 19 Newton will be 9.5 centimeter. So this we draw 19 Newton which is 9.5 centimeter and this we draw 8 centimeter. Then we open the compass 9.5 centimeter to this length, place it on other side like place on point A and draw an arc. Then open the compass 8 centimeter, place it on point B and draw an arc. And what will be the resultant? The diagonal here will be the resultant. And measure the length of this diagonal and that will be the resultant. And when you complete this figure, it should make a parallelogram. This is a parallelogram method. But what about triangle method? First we draw the first vector scale. You can select the same scale. First we draw the first vector. So we draw 9.5 centimeter, which was making 7 degree to horizontal. Then now we have to draw the second vector from this point. And angle is 74. So we'll mark 74 with horizontal and draw the second vector with a length of 8.5. And from tail of the first to the head of the last, so from tail of the first to the head of the last, that will be the resultant, and we call this as a triangle method. So both are the same techniques, but only difference in a parallelogram, we start both vector from same point and at the diagonal is the resultant. But in a vector diagram, we draw first vector, then we from the head of the first we draw the second vector, and the resultant is from tail of the first to the head of the last, that will be the resultant. Is it clear? Both methods to find the resultant. In part B, a force of 45 Newton is applied to a box at an angle of 30. Complete a free body force diagram. Assume that the surface is not smooth. So if surface is not smooth, the weight will act downward and the friction will try to oppose its motion. So the free body force and the normal contact force will be upward. The normal contact force is already drawn and the tension which they are applying with a string or the force applied. So one will be friction, and you should be you should draw the same length for the vertical vector. Why? Because vertically it is not accelerating, so weight is balanced with a angle 60. Which one is angle 60? The normal contact force is always acting perpendicular to the surface. The friction opposes the motion, because this force will have component F cos theta and F sin theta. So friction is opposing the motion. Yeah, this angle will be 60. That you can, but you don't have to mark the angle. You just have to draw a free body force diagram. Means you just have to represent the forces. Determine the normal contact force on the ground. On the box, the mass is 4 kilograms. So this one mass is 4 kg. The frictional force is there. The normal contact force R is there, and the weight is acting. And in this case, so when we apply the rule here, we'll divide this force into component. So the one which is with an angle, this will be 45 cos theta, and against the angle will be 45 sin theta. So this will be 45 cos 30, and this will be 45 sin 30. So normal contact force is acting upward, 45 sin 30 is acting upward, and weight is acting downward. And the vertical plane, there is no acceleration. So we can write the equation. We can write that R plus 45 sin 30 minus the weight is equals to 0. So R we are finding 45 sin 30. The mass is 4, so weight will be 4 multiplied by 9.81, and that's 0. So we will solve for R, which will come out as 16.7 Newton. Question 20. Physical quantities are either scalar or vector. Select a row which correctly identify a scalar quantity. So force is not a scalar, mass is a scalar, time is scalar, velocity is not scalar. And velocity is a vector, time is not vector, force is a vector, and mass is a scalar. So the correct answer, that time is scalar and force is vector, that is C. In question 21, a car is towed by a truck using a rope. The car is pulled at a constant speed, creating a tension T. The horizontal force acting. The magnitude of force exerted by truck on the car. So the force which the truck is exerting on the car, that's equal to the tension T. And T minus F will be equal to, as it is pulled with a constant speed, so T minus F will be 0. So C is the right answer. T, T minus F will be the resultant force which will act on the car, and that resultant force is 0. As they mentioned, it is moving with a constant speed. In the question, they are asking magnitude of force exerted by the truck. So what force truck is exerting? Truck is exerting a force which is equal to tension. And the resultant force on the car will be equal to T minus F. Is it clear, this question? So C will be the right answer. If they ask what is the resultant force on the car, then D will be the answer. Resultant force is 0. As they mentioned, it is moving with a constant speed. A girl dropped a stone into an empty well. She heard a sound, stone hitting the bottom after 4 seconds. The depth, so how we can find an object is dropped from certain height, initial velocity is 0, so S is equals to ut plus half at square. For falling object, u is equals to 0, so S is equals to 1 by 2, and acceleration will be due to gravity, gt square. So S is equals to 1 by 2 into 9.81 into 4 square. 4 square is 16 divided by 2. That is 8, and 8 multiplied by 9.81. So it will come out as 80 meter. C will be the right answer. In question 23, a student carried out an experiment to obtain the value of acceleration of a free fall g. A small ball was dropped from rest and the motion of the ball was captured using a digital camera. The student counted the frame from the recording to measure the time t between the ball to fall to the ground. A ruler was visible on the recording to enable the student to measure the distance fallen by the ball. Use Newton's second law of motion. Show that acceleration of a ball is independent of its mass. So how we can show acceleration does not depend on the mass? We, according to Newton's second law, that resultant force is equals to ma. And for falling object without air resistance, weight is the resultant force. So resultant force is equals to weight, and weight is equals to mg. So mg is equals to ma. M will cancel with m. So a is equals to g, or g is equals to a. So it shows that in the expression of acceleration, it does not include mass. Then state equation student could use to calculate. So student is measuring a time and distance. So he can use S is equals to ut plus half et square, in which the initial velocity is 0. So S is equals to 1 by 2 gt square. A value of a g was obtained and was a greater than the expected. So he's getting a higher value for g. One possible source that could lead to a greater value. So you can see that g s is equals to 1 by 2 g2 square, or g is equals to s multiplied by 2 divided by t square. So if we get a higher distance, if we measure a greater distance, we'll get a higher value. If we measure a short time interval, then the gravity will be higher. So maybe the parallax error in there in measurement of the ruler, the distance, greater distance was measured, or larger distance was than actual. That's why we are getting a higher value of a g. Or the time which is recorded, like the ball might drop before the camera start recording, so we'll get a smaller time interval. So if you get a smaller time interval, the value of the g will increase. Or you can also say a ball is thrown instead of being dropped. That could also be. But normally, because they're asking a ball was dropped before the camera started, instead of throwing, because what we need, as they mentioned, specify here, the ball is not thrown, the initial velocity is 0. A small ball was dropped from rest. So in the question they specify that it is being dropped from rest, so you cannot mention the ball is thrown. It's not acceptable according to the question. In question 24, The aeroplane is pulled backward and released and then moves forward in a straight line. Acceleration time graph is given. Acceleration is constant, then constant, then no acceleration means constant speed, and then again constant deceleration. So that the maximum velocity of airplane is about 3 meter per second. So A is equals to V is equals to U plus AT. Initial velocity is 0. Acceleration is 2 because they're asking for maximum velocity. So V is equals to U plus AT. Initial velocity is 0. So A multiplied by T will give us V. Acceleration is 2, the maximum acceleration. And the time it will take is 1.6. So 2 multiplied by 1.6, which is equals to 3.2 meter per second, not square because they are asking for maximum velocity. On the axis, draw corresponding velocity time graph for the airplane. The time axis is being and calculate the total distance travel after the release. So first, for 1.6 second, it moved with a constant acceleration and the speed was 1.6. Maximum speed was 3.2. So this is 1. So this one is 1, 2, 3, 4, and same thing, minus 1, minus 2, minus 3, minus 4. So for 1.6 seconds, it reaches 3.2, and it was a constant acceleration, so straight line, constant acceleration. Then you can see from 1.6 second to 3 seconds, it moved with zero acceleration. Zero acceleration means constant speed. So it moved with a constant speed for from 3.2 from 1.6 seconds 3.2 and 1.6, and then from 1.6 zero acceleration is there, and then there's a constant deceleration you can see, and at what point that there's a constant deceleration, so speed will decrease, and eventually at 7, from 3 to 7 it's a constant deceleration, so straight line horizontal line is there for acceleration, and at 7 second it stops, so speed will decrease and it will stop at 7 seconds. So this is the graph, and then they ask for distance travel. So how to calculate a distance travel? Distance travel is area under the graph. So you can take a trapezium, half sum of the parallel side into height. So starting from 0 and the maximum is 7. So this is 1 parallel 7, and this is starting from 1.6 and ending at 3. So this is 1.4. So half sum of the parallel sides, that is 7 plus 1.4 into height, the interval between them, that is 3.2. So multiplied by 3.2, you'll get the total distance, which will come out as 12.6 meters, or 13.4 meter, because the calculation shows 13.4. Is it clear, this part? So you should be able to use the values and complete the question. In question 25, a lorry gradually accelerates from rest There is a box of mass 200 kilogram. The box is not tied to the lorry. The lorry accelerates from rest to a speed of 15 meter per second over a distance of 39 meters. So that acceleration of a lorry is about 3. So how we can show the acceleration is about 3, as we have the initial velocity, the final velocity 0, we know the distance, so we can use the formula 2as is equals to v square minus u square. So 2 acceleration we are finding, the distance is 39 meter. It reaches a speed of 15 meter. So 15 is the final and initially at rest. So the value of the acceleration will come out as 2.88 meter per second square. And the acceleration of the lorry will be same as the acceleration of the box. The maximum friction between the lorry and the box could be 630. So why this limits the maximum acceleration that a lorry can have without falling, without the box falling off? Your answer should include a calculation. So this is the maximum friction or the friction force, because for a box to have the same acceleration, the resultant force F is equals to ma. So friction between the lorry and the box is 630. That is the maximum force which the friction can apply. It cannot increase more than that. So resultant force is equals to m. A box is accelerating with a lorry. So what could be the maximum acceleration? We can work out or compare the maximum friction force. As I mentioned here, the maximum friction force between the lorry and the box could be 630. It cannot exceed more than that, and that limits the acceleration of the lorry. So 630, the mass is 200 and acceleration. So maximum acceleration for a box, it can be 3.15 meter per second square. It cannot be more than that. If it is more than that, then the box will fall off from the lorry. Once the lorry has reached its destination, the back of the lorry is lifted and tilted at an angle of theta. State the expression. So the parallel component, so W, this will be with an angle, so against the angle, so with an angle, this will be W cos theta, and against the angle will be W sin theta. State expression for the component of a weight of the box parallel to the back of lorry and perpendicular to the back of the lorry. So parallel to the back of the lorry, that is W sin theta, that's parallel, and perpendicular is W cos theta. Because they're asking parallel to the back of the lorry. So this is the back of the lorry, parallel component of the weight is W sin theta. And perpendicular component to this is the back, so perpendicular component is W cosine theta. The angle theta is increased until the box is about to slide down. The friction is 0.3 R. Calculate the value of a theta. The box is about to slide down, so we have the expression, this is W cos theta, and this will be W sin theta. So we can say R minus W sin theta is equals to 0. It's about to, so we consider the resultant force is 0 at that moment. And friction, because this is a friction, the friction force minus W sin theta is equals to, here R minus W cos theta, not sin theta. R is upward, W cos theta is down. So R minus cos theta is equals to 0 and F is equals to F minus W sin theta is equals to 0. And the value of the F is given 0.32 R. So this is 0.32 R minus W sin theta is equals to 0, or I can say 0.32 R is equals to W sin theta, and here R is equals to W cos theta. So when we compare the two equations, or here R will be equal to, or I can divide even the two equations, like this is equation A and this is equation B. If I divide B by A, so B equation B 0.32 R is equals to W sin theta. So 0.32 R is equals to W sin theta divided by R over W cos theta. So W will cancel with W, R will cancel with R. So 0.32 is equals to tan theta. We need theta. So theta is equals to tan inverse 0.32, which will come out as 18 degrees. Not 180, it is 18. Is it clear? Discussion. So this was assignment related to motion, graph, and forces. Any question related to the session today?